Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Ed Page. Now, Ed is the primary maintainer of CLAP, which if you've been in Rust for a while, you've definitely probably heard of the library CLAP. It's CLI, I'm trying to think of the right way to even call this thing. I would say it's like an argument parser if you're going to be making some type of CLI or some type of command line application. Maybe there's a better way for you to say it, but why don't you go ahead and introduce yourself, Ed, and maybe you can help me correct how you would actually introduce CLAP.
So, Ed Page, I've been in the Rust community for several years now, participating in various projects, mostly around command line tooling, and most recently gotten involved with CLAP. So, probably the simplest way to describe CLAP is just, I didn't even realize this until I started maintaining CLAP, that's actually, I think, an acronym for Command Line Argument Parser. And so, that's probably the simplest way to describe it. It takes care of parsing command line-like operations into a generic data structure that you can then read the values from. And it takes care of a lot of validation rules, so that way you can have nice error messages for your user.
Yeah, I think I do remember that. Yeah, so I think for people who maybe still don't quite understand what that is, how would you relate it to something else? Like what are kind of similar kinds of libraries?
So in Python, there's argparse. Boost has, I think it's called program options, and I don't remember what different libraries there are from the different ecosystems, but for a Rust audience, an easy way to think about it is run cargo. You have to pass a lot of different arguments in to perform different operations on cargo, and it generates a help message. That's all being powered by CLAP.
Oh, wait, so CLAP is already included inside of cargo?
Yes.
Oh, I had no idea, but that would make sense, right? So it's kind of like dog fooding a little bit to a certain extent with Rust, where you actually kind of put your own libraries into it. That's great. Okay. So, I did make the mistake when I invited you, but it's okay to kind of bring it out. So you weren't the actual creator of CLAP, but do you know, what was the reason? Why do we actually have to have CLAP? Was there nothing in kind of a standard library that can handle this kind of stuff? How was Cargo getting along before we actually had CLAP?
So all the standard library provides is a way to be able to iterate over the arguments for your program. It doesn't allow you to interpret them in any kind of way. Before CLAP, so I'm not too sure the exact timeline of everything. I believe there's something more GitOps-like for those who are more familiar with that C and Bash approach. And I know for at least a while in parallel to CLAP, there was Burnt Sushi maintained docopt, which allowed you to instead describe your command line by the help output, and then it would parse that output and then parse your arguments based according to that. And I don't remember, the cargo team has mentioned before what was used before CLAP. I don't quite remember which one it was that they were using before, but then they did switch to CLAP, and they've been using that for a while now.
Do you know why did they switch to CLAP? What makes CLAP better than other kinds of solutions out there?
So at the time for the solutions that were available, CLAP had a lot more features, and it had a lot more maintenance behind it. For example, docopt, one of the other challenges with that is I know Burnt Sushi moved away from it because there was just a lot of different performance issues with it. The fact that it was having to do this parsing of help output to be able to then do anything else, and it was doing that at runtime, and I don't remember what other performance issues docopt had. So I would say probably more relevant for the conversation now is why CLAP compared to the ones that are out today. There's several other parsing libraries out right now. Probably the main way that those other ones set themselves apart is they have faster build times and smaller binaries. Where CLAP sets itself apart right now is it has a lot richer set of features. It will generate its help output while a lot of the other ones won't generate the help output. It will produce these nice error messages and allow you to add different kinds of declarative logic constraints so that you get good error messages. You get a lot of validation through the process and get those good error messages. It has suggestions of, you typed this, you probably meant to type this. And the other big one is, on some platforms like Windows, the command line arguments might not be UTF-8, and so some of the parsers that are out there, they actually will only handle UTF-8, and so they fail on Windows for handling some of these invalid paths or invalid UTF-8 paths and other things. And CLAP is something that actually handles all those very well. So, and a lot of these different features that sets CLAP apart.
Actually, you brought up a very good question I wanted to ask, and I'm afraid if I ask it later, I'm not going to remember. If I remember correctly, Windows, it does things for people who are used to Unix type kind of style, quite different. what I call, I don't know if this is the right term, but you can correct me. What I call switches, right? Like if you say like dash U or something like that, that dash style thing, they're different in Windows, right? There's like a backslash, I think, instead of or sorry, there's a forward slash instead, right? Something like that. So does Clap handle this for you automatically, or just like whenever you use Windows, it has to be this way, or you actually can handle the hyphens?
So Windows DOS-based programs traditionally would use slash for arguments, and then to separate an argument or for options. And the way to separate an option from a value associated with it used colon. While on more Unix-like platforms, it's double dash and an equal sign. And then there's been a lot of movement of more Unix-like tools to Windows. So you get things like ripgrep, which uses clap, so that people there have to use the more Unix-style approach. Then, if I remember correctly, PowerShell uses a single dash. So there's actually kind of a hodgepodge of things that are supported on Windows. So the clap's current behavior is exclusively the double dash, the more POSIX Unix-like approach. So that doesn't really stand out too much because of all of the other mixed scenarios on Windows. But that's one of the things that we are right now brainstorming on designs is how to make clap more flexible to handle people's needs. And so we're actually looking at separating out a lexer from clap itself and allow you to change out the lexer so that way you can handle double dashes, or you can handle slash, or you can handle single dash, or whatever other style it is that your environment requires, so that you can still use clap while being able to adapt to those specific situations.
So does this mean that we could possibly use, I don't know, emoticons like smiley face or a poop emoticon to have that as a delimiter?
If you know how to be able to get those characters in your terminal and you want to keep doing that every time, you could be able to do that if you wanted to. I wouldn't recommend it.
Wow, this is getting exciting now. I think I might start taking a look at Clap and maybe doing some very interesting stuff, or maybe start using like the, what do you call it, the Greek question mark, if you've seen that one looks like a semicolon. Let's kind of go a little bit back to your background, right, to kind of get an idea about who you are. So you're originally from California, is that right?
Yes.
But now you're located in Austin, Texas. Like, what brought you to Austin?
Just graduated college and my first job took me out here. I was doing a lot of systems programming, like I was doing a lot of stuff on either side of the user kernel boundary, either doing some kernel driver stuff for a test and measurement company, or I was then supporting a lot of the drivers with the user mode support side of that, with the APIs for adapting applications to it, or the test and control type of, I hate to put it this way, but those really annoying print dialogue programs that you have, something the equivalent of that for the test and measurement industry. So I was doing a lot of that kind of stuff. I was a C++ developer. At this point, I've known C++ for probably 20 years, and I'd always just been looking for that language to replace C++, because for however much I like C++, I also recognized its faults, but every language that came out that was meant to be a C++ killer just didn't satisfy the areas that I was using it. So Java came along, didn't quite solve it. D came along, and there was just a lot of issues with the early history of D. Go came along, and that's, again, originally there was all the talk of it being a systems language, but again, it's more of a Java light in terms of the applications it targets. That's what got me really excited about Rust. When I saw it come along, I'm like, I can actually use almost the entire language in kernel environments without compromise. I can actually use regular libraries. None of this like freestanding stuff that they're still arguing about in the C++ community, but I can actually just go and use Rust, and that excited me. And so that was kind of a personal goal at that point for myself, was I want to help make Rust succeed. I want to help make Rust be the replacement for C++ because there's something that's finally possible to be there.
Actually, I'm kind of curious. Have you ever taken a look at Zig before? Zig, I think, is also heard of a C++ or C killer.
So yes, it's still early in its development, and there's one of the things I appreciate about Rust compared to Zig is just the fact that it does help you in a lot of the ways. It helps offload a lot of your thought processes because it does a lot of the checks. So there's still a lot of interesting things about Zig. Kind of the way I think of Rust versus Zig is like if you were told to go and create C from scratch. And I think of Rust as told to create a C++-like language going back to a C mentality and doing it all over again. So you have a lot of the powerful language constructs, but it feels a lot more C-like in terms of the focus on structs, the focus on file scope, and different aspects like that. But there's still a lot of interesting things to follow in the Zig community, and a lot of things that we can be able to learn and apply from the Zig community.
What kinds of things you think would that Rust should take influence from Zig then?
One of the great things that's come out of Zig recently that there's just been a lot of talk in the Rust community about is the cross-platform compilation story. The fact that Zig comes with a C compiler, it comes with all of the glibc symbols and whatever else you might need to be able to cross-compile from one platform to another, for one version of glibc to another, and that's just something that reduces a lot of burdens for developers.
Yeah, that's definitely something that at least I notice in Go. What I liked about Go is that I could just say go build and build whatever for whatever platform. I wish Rust had a better story, but I understand that having something like that is expensive to do, right? So you think that Rust is actually going to be able to start doing something more similar to this, or at least be better at it?
There is interest from enough developers on the Rust teams that I think that one day we'll get there. The main issue is just prioritization compared to everything else that the different Rust teams are working on, because there's a lot of room for development among everything that's going on.
Yeah,
Never
it's
ending
true.
list of projects.
For Rust, it's really too wide. I mean, it's good, it's wide, but at the same time, it's hard to coordinate on certain things. Like this one could be one to be coordinating on. But to get back, yeah. Sorry. This is my question, right? So I kind of want to get back to C++. What I've seen people talk a lot about is like, and even I had this when I started talking to some C or C++ people about Rust, is that they said, we don't really need Rust because we have, smart pointers, right? Was that the RAII? How do you feel about that? You've been doing C++ for a while. Like, do you feel it's anywhere near?
So that's kind of an interesting one, because I've seen a lot of developers take kind of the attitude of they see that there's two approaches that get them to the same place, so that they equate the two approaches without looking at what are the impacts of those approaches. So you can get a decent amount of safety with things like smart pointers, but then there's a lot of rules around them about how you construct them and how you use them to make sure that you don't run into problems. Like, I can't remember what they are, but I remember just there's just so many rules with C++ to actually do things correctly. But I think with C++, one of the interesting use cases I like to bring up is one of the first projects I got involved when I started using Rust is a static site generator, and it has a custom implementation of the liquid template language used in Jekyll. And I wanted to be able to improve the performance of it, and it was allocating memory all over the place. So I was like, well, would it be possible for me to start just reusing allocations and keep track of references throughout the entire program? I went and did it, and it actually succeeded and made a huge difference in the processing of templates. And I looked back at this and I realized if this had been a C++ code base, I would have never have done this, because the amount of analysis needed to make sure that all of your references live long enough would have just been tremendous. And then that analysis would have had to be redone anytime any change was made to the system. While with Rust, I was able to just write it and go, and I'm like, I'm done. I've even tried to make further performance improvements, and I thought I did my own analysis and I thought it was going to be safe to do. And then the compiler found ways that I had missed and found that no, it isn't actually safe. And so that the borrow checker has saved me from having to think about these problems, and instead I'm able to focus on higher level problems, and it's helped catch it when I've done my own analysis and I failed at it.
Oh, that's good to hear. I'm happy to hear about that. I guess it really comes from the safety rather than just make sure you manage the resource, which is also part of safety, I think. What are you doing nowadays, right? What are you actually working on? Or maybe like where are you working and what are you doing over there?
So I'm working at Futurewei Technologies, and I'm part of a team that is meant to invest in the future of Rust. We are independent of any kind of product development. We are not really being told from corporate, we need Rust to have this feature that doesn't make sense in Rust. There's none of that kind of oversight. It's a lot of it is we came together, we analyzed what's going on in the Rust community. We've created a bunch of here are things that could be improved. What's kind of the theme or focus we want to have? What's our niche for being able to improve Rust? And we decided it's not an official goal, but kind of as an unofficial goal, we want to be the finishers. We want to take things that haven't been able to get over the line because it's a lot of people are doing this professionally. They don't have the time dedicated to do that last 20% of the work. We want to go in and do that last 20% of the work on different projects to be able to finally get things over the hurdle. That's something that was especially a conversation several years ago, where Rust used to have a more consolidated roadmap as the project was smaller, and they used to collect feedback on what should be worked at. one of the common conversations was there's a lot of things that have been started, but things haven't gotten over the line to being finished. And there's a lot of these half-baked things in the language and in the community. So that's kind of the thing that our team has focused on. That's how I got involved in CLAP in the first place is, well, in two ways. First, I was involved previously with Rust used to have working groups, domain-specific groups that are trying to improve things. And I was part of the CLI working group. And then I got brought on with Futurewei, and they were talking about wanting to be able to go and finish things. I'm like, one of the things that needs to be finished is the CLAP version 3 release. And so that was one of my first projects, was just helping to get all the bugs and features implemented needed to get the CLAP 3 release out. And since then, I've transitioned. I'm still doing work on maintaining CLAP, but my current kind of finishing project is to get cargo edit into cargo. That's things like being able to do cargo add Serde, and you now have Serde added to your dependencies.
Do we actually need that? Because I was looking at that, but I was just wondering, do we actually need that? Because if I go to the, sorry to kind of pick fun, but I kind of want to play devil's advocate, right? Because if I go to the TOML file, I could just add it in myself by hand. Sure, it's a couple more steps, but at least I can guarantee that the version is what I want it to have. Or this actually is already being addressed.
So that's a very good question. That's something that, as part of the proposal, I needed to figure out what is the value add, because for me, I've not used it. Part of the issue for me is I don't tend to install a lot of third-party cargo tools, and so that was the main reason I never really considered using it. And I think the value add has changed a bit as I've tried to polish cargo add in preparation for being merged into cargo. I would say there's a couple of benefits to cargo add versus just editing the TOML file directly. I think the way I try to think of it is, think of it as more like having Rust Analyzer for programming Rust. You don't need Rust Analyzer. You can go and do everything yourself in Rust. I actually personally don't use Rust Analyzer, but a lot of people still provide value out of it because it helps just to smooth out a lot of different workflows. So with cargo add, it is a lot of times people, like, for me, I'm kind of lazy. I don't go and look up a specific version of a crate. I'm like, I just want to use the latest version, and I don't want to have to go to crates.io to copy and paste the latest version in. So a lot of times I'll just say Serde equals 1, and just, that's not that great. There's a lot of different problems with being that generic with my version constraint for Serde, but I don't want to go and look that up, versus if I use cargo add, I can cargo add Serde and it'll automatically put in the latest version for me. It will also take care of a lot of other best practices or other things you should be doing. Like, one of the things that I didn't know for the longest time is you actually don't need to specify. So if you have a workspace and you need to, like, let me be more concrete with an example. With clap, we have clap and clap derive. Clap derive allows you to basically declare through attributes on a struct, declare how you should parse your command line into filling in the fields of that struct. And we had the tests inside of clap derive. So there's a situation where clap derive depended on clap and clap depended on clap derive, but one of those directions was only for testing. So I didn't realize that the way you can be able to solve that is just not declaring a version constraint, because this is set up in a workspace. It's using the paths for resolving things for development. But at publish time, it doesn't need to know about this relationship because it's just a development dependency. It's just for tests. So you can leave off the version for clap derive onto clap. You don't need to specify that. And so that's one of the other things that cargo add will just do automatically is, if you're adding a path dependency, you can just add the path dependency and it will decide whether it needs the version in there or not. You can also just go ahead and use autocompletion, because you can say, if you have path dependency, if you're using a workspace, you can say cargo add // /t tab, and it'll just complete it for you and run that, and it'll go ahead and pull out things like the version and the crate name for you, rather than you having to go and make sure you type all that information in correctly. It'll look, some other things that cargo add does is it'll look up and help validate the fact that what features you're providing, or do you actually type in your feature names correctly? It'll tell you that kind of stuff, or tell you what features are available for you to add. So it has just a lot of these little nice to haves things to help smooth out a workflow. By itself, like for me, it's never been worth it to just install it. It's more of, if it's already there, it helps to smooth out and improve your workflow.
I mean, it sounds really useful. Like, aren't some of these things actually going to be merged in? So I do see over here, you told me that you're working on merging in cargo edit. Like, why is cargo edit a candidate to be merged into mainline cargo versus cargo add? Because cargo add, when you're describing it right now, I'm actually interested to try to add it.
So that's maybe something to clarify. There is no program cargo edit. Cargo edit is just the repo name for all of the manifest editing command line tools. So that's the repo name for cargo add. There's also a cargo RM for removing a dependency, cargo upgrade for changing in your manifest file the version. So if you want to go from clap 2 to clap 3, you can cargo upgrade clap and it'll modify your manifest file. There's also one that I created that's kind of experimental, not sure how many people use it, but cargo set version. This is mostly helpful for automation or for workspaces. So say I'm in clap, as I mentioned, it's a workspace. We have clap and clap derive. I can run cargo set version on clap to set it to version 4, and it'll automatically update clap to depend on that version 4. I don't have to manually edit all of the dependencies within the workspace to point to the correct version. It'll just do that for me. So there's all these different tools within Cargo Edit, and we felt that Cargo Add was the highest priority one to get in, and then I'll slowly work down the line evaluating whether it should be merged into Cargo and what's the best way to merge it into Cargo, and just work through that process.
Is this like a working group that's working on all these things, or how do you decide what goes into cargo?
Part of it is community interest, community feedback, and part of it is talking with the Cargo team to see what they're willing to take on. The Cargo team is, like a lot of Rust teams, is stretched thin, and so having somebody being willing to do the work and to keep maintenance of it after the work is done is something that definitely helps with trying to get something into Cargo. But otherwise, they also have to weigh out like what's the impact overall to Cargo, and they felt that this was something worthwhile. So it's basically I'll basically do the legwork of figuring out what might be worth merging into Cargo, double check with them to see, hey, do you guys agree? Here's my thoughts, here's my proposal, and I'm going to go ahead and do the work so you guys don't have to. And they give a thumbs up or thumbs down.
Okay. And so this is Futurewei's kind of priorities, that really making sure that Rust is going forward, right? Like you said, doing the last 20% to really make things more complete.
Well, as a company, for our team, Futurewei's primary concern is just making sure that long investment in Rust, making sure that as they switch different products to be using Rust, that Rust will be where they need it to be in the future. And so for us on our team, we've internally made that decision to work on finishing things. So again, like we are very much decoupled from management and from different processes and products. In a lot of ways, our driving decisions, we're just told, make Rust better for the future. And we as Rust community members are deciding that and not the corporate.
So how do you guys decide on which one should be done? You said that used to be before was quite clear with some surveys. Now it's kind of like some internal discussion and you guys say yay or nay, or how does that kind of work?
So even within our different areas, we're mostly working independent, though we do some coordination. So when we first formed our team, we just went through and looked through a lot of unfinished things, and a lot of it is just from our own interaction with the different Rust teams. Some of the people are on Rust teams, and just seeing what needs to be done and work on it just as if they were contributing in our personal time. Like whatever we do in our personal time is basically what we're doing now as part of these teams.
So nobody from Huawei or Futurewei will come up to you and say, hey, we need you to spend some time on this one because we need some features or something?
So far, I'm not aware of that happening.
Almost sounds like a dream job of kind of anybody in the OSS, is that they just want to get paid to work on stuff and just enjoy their time.
That's why I couldn't pass up this opportunity to work with Futurewei. It sounded too good to be true. One of my teammates is Jane Lesby. I reached out to her to double check, like, wait, is this actually true? And she told me yes, so went ahead and joined.
I mean, it's good. I'm very happy about that. There's different, I feel like this is the last 4 years, it's been places, it's been, how do you say this? There's been people experimenting with ways of how can they help, right? So instead of just throwing money at something or not doing anything, it's like, okay, should we hire somebody and then do it full time? Should we put money into a fund, is what I've been hearing from somebody else. There's different ways to do it. And this is definitely an interesting way to do it. And it's even more strange that you can just say, okay, we trust you, just go make Rust, keep going, So I guess they must have looked at your laurels and just said, okay, this guy, he seems like he knows what he's doing. He's making stuff better and we can invest into him to keep this thing going.
And I think the funny approaches also have a big impact on each individual person. There's some people who are willing to do contract work and willing to do a lot of small contracts where it's like, or just take general funds through different donations that GitHub supports and things like that. I'm somebody where the donations, I don't make a difference because I was either working full time or I'm working on my side. And if I'm working on the side, I'm just going to do whatever I want to do. So the money won't be telling me what to do. And when I'm working full time, I want a salaried job. I don't want to have the uncertainty of being on contracts and just worrying about how much money I'm going to be getting in. And so this is something that works well for me, while other people really like the contract and the donation approach. So adapting to the different needs is a very important thing. And there's been a lot of times where I've done work on different projects so far, and I've thought back and I'm like, this would have never been done if this was part-time development, because there's just not the time to do something this grueling or this mundane, because it's just hard when you're working part-time, when you're working on your evenings and your weekends to work on these projects, to go and do some of that more mundane work that it's hard to be motivated for. It's hard to justify it. But when you're working on it as a job, it's much easier to say, okay, I'm going to go and do this mundane thing that's going to take 3 hours or a couple of days, that is going to offer long-term benefits, but it's just not going to offer immediate benefits.
So are they hiring right now? Because maybe I'll apply. Sounds like a pretty sweet gig to me.
So I don't remember fully what our hiring situation is. I think we're talking about looking for some interns, and I think our team is made up of mixture of salaried and contract. And I believe we're looking at expanding our contracted employees, but I also know that there are different regions that Futurewei is hiring versus Huawei is hiring. So I don't know all of the particulars of hiring, but I can always reach out to somebody if they have to answer questions if somebody has them.
Okay, just keep me in mind in case you see a spot open, all right?
All right.
Yeah, this is pretty exciting. Like now I kind of want to go a little bit more about like what kind of stuff have you worked on, right? So maybe we can kind of talk a little bit about when you first started getting into Rust. So I think a lot of the bigger people like Carl Lurch and things like that, people like that, I mean, they kind of got started with something and then they ended up yak shaving and then they're still shaving the yak for until now, right? So, you said Cobalt was kind of your first endeavor and then that kind of took you to Clap, or like what happened when you got into involved?
So when I was first learning Rust, there was two problems at my job that I wanted to write a tool for. One was we had kind of a linter with regex defined rules, and I wanted to fix several different problems with it. I also had just run in too many times where programmers had misspelled some variable name in the code, but it was in such a place in the code that it would just be too expensive to be worth fixing one missing letter. And so I was just like, what's a way that we could be able to make that problem go away, make it so we don't have to worry about this thing. So it's like, okay, so my first two projects in Rust are going to be to work on those. And I started to work on them, iterate on them, and I was like, well, I want to be able to write about some of my experiences in learning Rust, so I want to have a blog. What's a blog software in Rust, so that way I can kind of keep everything themed together. So I started using Cobalt, started contributing to Cobalt. That led me to running into some issues with a testing library I was using. At the time, it was called Assert CLI. So I started interacting with the author there, Pascal or Killer Cup, and contributed some changes there, made some improvements. He was then forming the CLI working group and invited me to participate with all of the focus I've had on testing CLIs. And so that's led to a lot of other kinds of work along that route. And that's kind of like, and then related to Clap, around that time, Clap's maintenance was starting to, the level of time for the maintainers was starting to drop down. So we were being asked to help out. My own personal development time was also starting to drop down around that time. So I couldn't help Clap at that time. But again, like when I got more time when I was brought on at Futurewei, I was like, okay, I'm going to go back and do that work that I wasn't able to do before. So that was kind of my yak shave story of I set out to write two programs and I've gone almost everywhere but those two programs. I eventually came back around and wrote one of those, the spell checker. It's called Typos. I've never ended up writing the other one just because it was such a specialized need that I've just not had a reason to solve that at this time. But Typos works pretty well. It's pretty smooth.
Yeah, I was looking at that. Typos is pretty interesting. And like for me, I'm very interested in doing some very, what do you call that, very colorful kind of CLIs in these command line apps. Yours has colors and stuff into it. Like what kinds of crates are actually letting you do all that?
So that's an area that I think there's still some immaturity with the story around of doing colors. The one thing I avoided adding to my programs for a while is just because it was unclear of within all of the things related to colors of what's the best approach to be able to go. So it wasn't until I worked on another program, GetStack, where I'm like, okay, I really want this to be fully polished. I'm going to go ahead and do colors, that I tried to even look into this. And there's just a lot of different directions to go. There's probably 5 or 6 different worthwhile actual coloring crates depending on your use case. And then there's other related problems to colors, like detecting the capabilities of the terminal. That was one where I wasn't too satisfied with how any of that problem was being solved. Later turns out there were some crates that exist that I just didn't find, but I went ahead and created, I'm experimenting with called con color control, basically, is what that's short for, or just for fun, with color in Spanish. And so I created that as a way to be able to help detect terminal capabilities and help control whether I should actually be using color in my application or not. And so I've got some PRs and discussions out with some of the different coloring crates to be able to get that integrated into them. So the other main problem I see right now with the coloring crates is, for example, with Clap, a lot of people want to have to customize a lot of the styling within Clap, but for us to do that, we'd have to expose which coloring crate it is that we're using, and that's not something we want to do for API stability. So that's one thing I think that could be really beneficial is if we provide a way for there to be a here's the definition of coloring that is reused by all of the different crates so that we can actually have you can actually change out crates. You don't have to worry about a crate bumping its major version or any of that kind of stuff. You'll always have this well-defined subset of information that just works across all of the crates. So there's some problems still with coloring, I think, to make it as smooth as it should be, or as smooth as, say, some of the JavaScript libraries I've seen popping around. But I think we still have some good crates out there. Like there's, if I remember correctly, it's called Term Color, which is what RipGrep uses. That's very focused on being able to support legacy Windows applications. Then there's OWO and Yancey, which provide a really nice user experience, but to only work with newer versions of Windows and Mac and Linux. So there's things out there, there's things to be able to use, and it really adds a nice touch of polish to a program to add coloring.
Yeah, definitely. I didn't think that coloring would be so difficult to work out, but yeah, I can imagine that people would want to use Clap, but then they want to have like, I mean, there's gonna be people who just give me the default, right? And there's gonna be people who's gonna say, you know what, I really want to make this very sexy and beautiful, right? So how does Clap handle this currently? Where how customized can you be?
So another use case somebody specifically brought up is this is our branding for our application uses these colors. We want those colors to be used everywhere, including within Clap. And Clap has a fixed set of colors, so it's not conforming to the branding, and that's unfortunate. Right now, Clap doesn't offer any control. That part of the problem is we don't want to expose those internals, like what library we're using. We also don't want to have to effectively make our own terminal styling crate and embed it within the Clap API to wrap anything that's underneath us, which is what would basically have to happen to be able to support these customizations. So right now, there is no customization. It is not great. It is frustrating. I understand that the people who have that problems with that. Our current thoughts for how to move forward with that. Our primary one is we're looking at kind of modularizing Clap and making it more flexible to be able to pick and choose the pieces you want. And one of those is going to be looking at making it so you can provide your own help generation, and by taking our help generation and customizing the behavior of it. So we'll help create all of the order everything, and you just say like, okay, I'm going to do the coloring for these parts here, and you then handle that yourself. So you can customize the formatting or the styling while we're providing all of the other kinds of formatting for your help output. And so that way people can be able to do that extra little bit and get that customization they need without having to expose our internals or take on a whole large API just to be able to support these not as common use cases. So I'm
Hmm.
hoping that will help in the future. I'm also, maybe one day I'll get time to try and work on the idea of creating a crate for cross styling definitions of formatting so that way we can instead just rely on that. Don't know if I'll get there, but that would also be one other way of allowing this to be able to move forward.
Yeah, that'd be exciting if we could make it just a little bit more customized, but I can understand that it's not quite that flexible, at least not yet. But I think the main reason that you kind of came up on my radar is Clap just recently went to 3.0, right?
3.0 and then 3.1 just within the last week, yes.
Okay, so maybe we can talk a little bit about what's in 3.0, and I didn't know 3.1 came out, so what's in 3.1?
So the big thing in 3.0 is so Clap has this programmatic API where it uses a builder pattern to be able to define all of your arguments and all of the behavior on your parser. And there was this other crate that existed called struct_opt that allowed you to use a proc macro to derive your parser based off of attributes on your struct, and it automatically fill out your struct. So one of the big things from Clap 3.0 is we've brought that derive macro into Clap itself so people can be able to in some respects, it sounds kind of like your comment about cargo add versus cargo.toml, where it's like, what's the difference? The big difference of being able to bring the macro into clap itself is the fact that we're able to have a better feedback loop for making improvements, where as we were working on integrating the macro in and polishing up for release, it was like, well, this part of the macro really could use this change in clap. Let's make this change in clap to be able to make the macro better. Or like, oh, we just added this new feature to clap. Ooh, we need to actually change that feature to be able to work better with the macro. Or ooh, we need to make the macro work in this way to be able to really take advantage of that feature. So there's this design and implementation feedback loop by having them kept so close to each other. It might sound small, but one of the other great things I appreciate about Clap 3.0 is custom help headings, where you can be able to separate out, here are all of my arguments related to, I'm trying to think of one of my programs and what kind of grouping of arguments I might have. Like if you're working with Git and you're wanting to take a lot of Git operations, you could have a Git section in your help. Before, they were all just grouped all together. There was no logical structuring to your arguments in the help output. And so now that's able to be supported. Clap 3.1, the main focus of Clap 3.1 was to be a step towards a lot of our Clap 4 work, because we're trying to leave deprecations and things like that to being in our minor releases, so that way people more explicitly opt into them and they're more batched together. And so in Clap 3, one of the things that it did is it went dark. It was being done in a branch separate from Clap 2 for many years, and we're trying to avoid that. And so we're trying to do as much as we can in master as part of the regular releases, and then make it so the actual Clap 4 release is just going to be, okay, delete all of the deprecated code and we're done type of a thing. And so that was what a lot of the focus on Clap 3.1 was. We want the API to be in Clap 4 and see how close we can get to that now, just by renaming things or providing alternative functions and deprecating the old versions of things. And so that it's going to be a lot of churn, but we've got those renames in. A lot of any further churn is going to be a lot more corner cases, I believe, between Clap 3.1 and 4.0. So I don't think that's going to be too much of an issue for people moving forward. But I think overall that's going to improve the approachability of Clap for somebody that's new to it. But in terms of somebody might more directly be interested in, one of my favorite features from Clap 3.1, wow, I am forgetting this actually right at the moment. I'm going to have to pull up my Reddit post about this. Oh, yes. There's just one of the values of Clap is we're trying to just give you by default all of that little polish that you might have to go and hand implement yourself, like help generation. And so there was a piece of polish that I noticed in Cargo that I was like, I want this. I want this to be in Clap itself, where I never really knew this before. So if you are in Cargo and you want to run one specific test, you can say cargo test and then say dash dash test and give it the name of the test, and it'll run just that set of tests. But the thing I didn't know is you can leave off the test name and just say dash dash test, and it'll list all of the tests that are available for you to run. I'm like, that's kind of a nice little bit of polish where it's like, I don't know the answer to this. I don't know what I can put in this field. Let me just run it without the field and it'll tell me what I should put in that field. And so that's one of the things that I also added in Clap 3.1 is if you have an argument that takes an enumerated value, like a list of like 3 different values, potential values, if you leave off that value, we'll now just list out those possible values to the user. So that way it's like, for say my program git stack, you can tell it what to do for fix-up commits that are trying to modify a previous commit, whether you want to just move them to be after their commit they affect, or if you want to squash them. So if you run git stack with dash dash fixup and that's it, it'll go ahead and tell you what parameters you can pass to fixup. And then you can then go ahead and pass it and start using it. So that was just one of those nice little quality of life improvements, bit of polish that we added in Clap 3.1.
You said this is on tab, or this is you have to actually enter the command and then you have to re-enter with the selection afterwards?
So this is on hitting enter. We do also have the ability to generate completion support for Clap. So that is also another way of handling that need. I'm usually too lazy to set that up for my programs, or either the programs I create or the programs I'm running. So this is nice for that kind of a case. And ideally in the future, both for tab completions and for the help, right now, this feature that I'm talking about only in Clap only works if you explicitly tell Clap what the values are. we might not always be able to know at that time what those values are. Like with cargo test, it has to do a lot of processing to find out what all tests it might be able to run. It'd be great if we were able to tab complete that or include that in the error message. That's something that we're working towards in the future, is a lot more dynamic tab completion within shells. That way the program can be able to insert some special logic saying, I might not be able to know a priori what this should be able to complete to, but I can generate it at runtime. I can read config files, do whatever other processing is needed to be able to complete this field. So that's something we hope to be able to get in the future for CLAP.
Now, is that difficult to set up? This is something I want to do in my own program. I mean, that seems like a little bit of work, right? Because like I'd runtime kind of check for possible solutions.
Oh, if for when we get dynamic completion?
For completions was one thing, but I was just thinking just in general, if you say you press enter, then you can kind of let people know, like, these are the possible branches, right? There's something like that.
So the only area we support it natively in CLAP right now is, so say you're using the derive API. We have a derive for an enum. A common one is when a lot of programs support a color flag, -- color, always, never, auto. Those are just 3 values. They're compiled, baked into your program. With the derive API, you can actually create an enum for that, where the enum variants are always, auto, and never. And we'll derive it, and you can be able to have it so CLAP knows what this argument only takes the values always, auto, and never. And it'll provide an error message saying, hey, you typed something besides always, auto, and never in this for the color field. That's not correct. So we already know that information for the validation purposes. So now we're also surfacing it in the error message when you don't provide any value. So it wasn't too much of a change from what we already had in CLAP for when you a priori know what values are supported for a parameter, for a argument.
Okay. It sounds like when I was just kind of listening to you earlier, your future plans for CLAP is probably start breaking up into even more crates and then try to let people assemble their own version of CLAP so that you could do more customizations. Is that really part of it?
So yes, we want to be able to make it more modular so people can be able to pick and choose the pieces of CLAP that they need. But my hope is that that type of modularization work is going to be more for the 1% of users, the users where CLAP doesn't quite do it this way we'd want, and it's important for us to be able to do this way. If we can't get this, then we're going to have to do our argument parsing ourselves. That type of user that we're wanting to target with that modularization work, because it's just going to be a lot of work for somebody to manually wire everything up with this kind of a modularization. So we don't want to make it so everyone has to go through that effort of wiring up all these different pieces. We have a different modularization effort that we're hoping will be able to help the more users, where we want to make it so CLAP is more pluggable directly, where the validation rules and how you parse things and different things like that can just be passed into CLAP, where we don't have to have all of that logic baked in. That's something that I'm hoping will be a more smooth transition for users, because it's just going to be a matter of, hey, just pass this struct in with these parameters and then we'll do the rest, compared to, hey, here's this like half implemented help generator. You have to go implement the rest. So hoping that these 2 different approaches to modularization will help the majority of users and help the 1% of users be able to do more things in CLAP without just having to come to us to implement every feature. Because CLAP's design right now is very much you tell it what to do and it'll go and do everything on your behalf. And so that means somebody has to come to us whenever they need any kind of tweak to the behavior, whenever they need any change. We have to bake it directly into CLAP, and that doesn't scale, and that makes the API more brittle. And so us being able to not have to handle every single need within CLAP itself will be able to make it so people can evolve their applications as needed without having to go to us, and we don't have to have as many breaking APIs once we get to this ideal state.
What I wanted to kind of talk about for a second is kind of like some inspirations for CLAP, or what CLAP actually is looking at. Let's not talk about the elephant in the room that we both know about, because we talked about this before. I was trying to look through the notes, and you did mention like at least 2 other crates, or not crates, but 2 other libraries out there in other languages that I think I've seen. One is Charm, and the other one is something else with a C or something. I forgot the name.
Click.
Yeah, Click. So can we talk about what are those, and what kind of things do you think that that you're inspired from them, or what kind of things would you like to bring in from them?
So in general, I just want to make sure that we don't have our heads in the sand, that it's like there are a lot of people coming from other languages in Rust that we're able to get some inspiration from. We also need to make sure that we're not being insular and just clap is all I know. Clap is great because that's all I've been using for a while. But what else is great out there? What other innovation is going on that I might not normally see because I'm not going and doing JavaScript development, or I'm not going and doing Python development? So my hope is that we can be able to look outside our bubble and look at argparse, look at click, look at charm, and be able to see here's something that they're doing really well. Here's where it doesn't fit with clap, or here's how we can instead do things differently to satisfy the same need to be able to do with clap. And I welcome anyone to who's familiar with these, familiar with the different argument parsers in Go, in Python, in JavaScript, in whatever environment you are, to come into our discussion board and just post like, hey, these things that it does great. Here's some things that doesn't do well. Here's just in general, it's just analysis of it. I've started an analysis of Click. I still need to finish going through and reading the documentation for Click, but somebody who actually uses it day to day, that'd be great to be able to hear some of their thoughts. So that's something that'd be a great way for people to help out, is just what lessons can we learn from outside of our own little bubble of Rust to be able to pull in and be able to make things better. And that's something that we're like, because I'm already very familiar with argparse, that's something that I've already been doing of like, there's a lot of different ways that there's been tweaking of Clap's behavior. I'm like, well, there's one feature from argparse, this idea of actions. I think that could be able to help like take these like 5 different settings in Clap and consolidate them down and simplify them so we can better communicate what is happening within Clap. So that's an example of us trying to pull from another area to be able to make Clap better. And I'm hoping we'll be able to do that more. Like, for example, just seeing what kind of problems with Charm it's trying to solve with all the different features it provides. I know we have a feature request in Clap for prompting users when an argument isn't provided, and I see that that's in Charm. And so that dual, seeing it in 2 different places and seeing how it's handled in one can help provide API inspiration for how should we expose this to the user? What kinds of needs do they have, rather than us putting a version out there and it not quite working right and us just having to repeatedly break an API because it didn't work. If we can be able to look to see how other people did it, we can be able to use that for inspiration to better satisfy needs, because they've already been dealing with user feedback on how to prompt the user on the command, how to prompt the user for input.
Yeah, so charm is written in Go. Click is which one? What's that written in?
Or for some reason, I thought Charm was JavaScript, but maybe it's Go. I haven't been paying attention. Click is another Python one.
Okay, and then there's argparse, which you've mentioned, but I don't think we said before that it's Python. So argparse is built into the Python standard library, I believe.
Yep.
But Click, so why would people want to use Click over argparse then? Because I think that's the one I used before. Pretty solid, right? So what does Click actually bring you over argparse?
So Click, and one of the variants of Click, the immediate thing that you'll notice about it is it's kind of like the difference between Clap and Clap's derived macro, where Click, what it does is it relies on a Python feature called decorators, which are similar to just macro attributes in Rust, to be able to define your CLI on your functions themselves. So you can just define a function, put this decorator on it, and that function now has a CLI to it, instead of having to declare all of your attributes, declare all of your arguments, and reading all those arguments. It's a lot more of a declarative way of defining things. As I've dug into Click further, there's also a lot of philosophy differences between Click and between argparse, where they've had to go and re-implement their own lower level. It's not just built on top of argparse, but they've had to go and re-implement a lot of the lower level details because of those different design philosophies. So it's also like, that's one of the things I'm also interested in looking at, is like, what kind of design philosophies have they had, and would they help solve any of the problems that we're having with Clap? And those kinds of cross-pollination of ideas, I think, is very valuable.
Yeah, you brought up one before the show, right? I think it was something about using a dictionary or a hash map as part of Clap, right?
So yes, that's an interesting one where that's not even a super obvious way to be able to cross-pollinate ideas, where in Python, your objects are all just hash maps internally. Like, you can opt into something that acts more like a struct, but otherwise they're all hash maps. While in Rust, you define a struct and it has all of your fields and they're all statically defined, which that Rust approach is great. It offers a lot of performance benefits. It makes it so you get a lot of help from the compiler in detecting errors and things like that. But with the way Clap has grown its feature set, with the fact that everything has to be baked into Clap to be able to work, we now have 20, 30 fields in a struct. And that means anytime you move that struct, it has to generate all of the assembly code for moving 20, 30 fields. One approach for solving that is generally used with errors is just to put that on the heap to box it, and then that's taken care of in some respects. One of the thoughts I had is, what if we could apply the approach of Python? Maybe we should be using more hash maps. And I think particularly so we get typing with it in Rust, like using any maps, that way it becomes typed. That way it's effectively you're saying this field can exist or not exist, but the field is typed, it can only exist in this one way, and it can have this one type data type of value. And so I think that's a way for us to be able to possibly make clap faster to build and have smaller binaries, but I'm also hoping that'll be a way for us to generate a plugin interface where you can attach any kind of metadata you want to an argument. Say completion support. We in clap 3, we added support for a value hint where you can say this argument is a path. So that way when you get to completions, we'll tell bash that this is a path. That had to be baked directly into clap to be able to support completions. What if we can be able to make it so completions can define all this stuff themselves, and they can then read that data, and clap doesn't need to be updated to be able to handle this completion specific use case. So we're hoping that by using an any map for a lot of the different kinds of state you might want to track with an argument, we can be able to reduce our compile times, reduce our binary size, and increase our flexibility while still getting a lot of the benefits of having struct fields by having it type checked with any map.
Now that we're kind of talking about things that we can do to improve clap, like what kinds of stuff is definitely planned and is maybe even in the process of being done to clap?
So there's a discussion board I have up right now that I'd love to get people to look at it and provide feedback on, so that way they can make sure that clap is going to stay in the direction they're going in. That's something that is actually kind of an interesting one for clap, where there's a tension between keeping things stable, keeping things working how they've always worked, and making things better for the new users, for those corner cases, and for like people who aren't currently being served by clap. And so in trying to handle that dichotomy, we're trying to evolve clap, but we also need to make sure we don't alienate the existing users. So I would love it if people could go onto clap's discussions. It's the pinned discussion right now, and go and provide feedback on it of, here are the designs that we're looking at doing to solving clap's problems. Make sure that those actually work for you. So tying that back into your question, we're working on coming up with the designs right now. We've not started implementation yet. And part of it, the reason I've not started on the implementation is I've been working on other projects like cargo add. And part of it is I'm trying to throttle my work so that way, because like if I just focus purely on clap and just work on clap, I'm going to quickly hit the point where it's like, we need to do a breaking change to be able to make any further progress. And we don't want to be doing those every 2 months. And so I'm kind of switching between projects to be able to make it so I don't get ahead of myself for when we can start doing breaking changes. But some of the things that we're looking at doing are, as I mentioned before, being able to plug in different lexers into clap so you can be able to handle different kinds of argument styles. And I also just, before this question, talked about the fact of making clap a bit more pluggable using these any maps to be able to just put in any state you want or any kind of validator you want. And also looking at adding action support so you can be able to define, here's the specific behavior I want when this argument is being processed. So those are the kinds of directions we're looking at going. We're working on the designs of them, but again, haven't started implementation yet because trying to focus on cargo add right now and trying not to cause too much churn for clap users.
Yeah, I have to keep watching clap, see what's going on. Yeah, I think I don't have much other questions other than actually, this is a pretty good question. So, some things you talked about that you said you want to talk about is you are trying to resurrect or keep alive the working group for CLIs. Is that still the case?
So there's one or two of us that are still, in some respects, keeping it alive. So as I mentioned, like back around the 2018 edition, there was domain-specific working groups that were formed to be able to look into improving different situations. We had a working group for CLI. We did some work. There's still a lot of work that wasn't done, like color support, like some of the things I've been talking about with color. And so some of us still are aware of that working group. We still have some of the crates. We're still trying to work to keep those crates alive, keep iterating on them. We have a CLI book that we maintain. So a lot of it at this point is keeping things alive, but it'd be great if we could be able to get some more new blood into that, get some people having conversations, helping to solve some of the problems rather than us each going off on our own direction, solving problems, coordinating on these things rather than just doing a less work, each of us re-implementing things in our own little ways to be able to instead coordinate that work together so we can accomplish much more together.
How many people are actually involved in that working group?
So back when the working group was active, there was, I don't know, 10 of us. Right now, there's just probably, I would say, I feel like it's mostly me, but I do see one or two other people occasionally doing some work in that area. So
So
it's thinned down a lot over time.
I say, is this a call to action? People should start hanging out in this working group now. You say you're looking for some fresh meat for the grinder, right?
It would be helpful to be able to have some fresh conversations going of people brainstorming how to solve problems, us coordinating our documentation, things like that. You can find us on Zulip. There's a WG CLI stream. There's also on the two different Discord channels, there's a working group CLI channel and a CLI 2E channels that we all hang out on. I find the Zulip one I'm more likely to get notifications for. And there is also a GitHub org rust-CLI. And there's a team repo within that for where discussions happen. So any of those places, it'd be great if people popped in with when you have conversations and when you coordinate to work together to make things better.
Yeah, actually, sorry, before I say enough of my questions, you did bring up something really interesting, which is that you're focused on as kind of a side project, so not really talking about clap anymore. This interesting little, like, what I guess I can call a mini or sub language of Rust out there called cargo script. Can we talk about like what is cargo script and why do you think it's something that people should start to take a look at?
So I guess to step back a little bit, so I've mentioned before that my background is a lot of it is in C++. I also had a lot of work that I've done in Python for either tooling at my companies. I've kind of shifted a lot from my systems programming to a lot more developer productivity, developer efficiency type of stuff, developer experience. So I've done a lot of developer tooling, and a lot of that's been in Python. Back in the day when the Nokia's MIMO platform existed, I did a lot of app development in Python. So I have a lot of experience on these two extremes of the spectrum of C++ for low level and Python for high level. And I feel like one of the things I've valued in Rust is the fact that we have these dichotomies between, say, memory safety without a garbage collector, where two things that we thought were opposites that couldn't be brought together are able to be brought together. And I feel like that's something that an area where we've not done enough. And I'm glad for this last RustConf for a lot of the conversations that are around making Rust easier of solving that dichotomy of how do we have this language that is able to solve all these, how do we have a language that's both designed well for embedded and can be an easy to use language like Python and help solve all of those interactive or exploratory programming aspects of Python. And so I think one of those areas that people bring up a lot is either one-off scripts or REPLs. And REPLs have a lot of their own challenges with a compiled language, but I think something that we can get close to that is with one-off scripts, with being able to just write this one file, throw my ideas in it, and go and be done with it type of a thing. I think that'd make it easy, like when reporting a bug, you could have an entire self-contained example that can compile and run just in a little code fence in Markdown. So there's improvements besides just the exploratory programming and the learnability aspects. So a tool that has been existing in the Rust community for a while that's just kind of languished is called cargo script. Script kind of implies that it's interpreted. It is actually a full-blown Rust code. What cargo script does is behind the scenes, it'll create a whole cargo project for you. And in your comment, you can put some of the data you'd normally put in your manifest file, in your cargo.toml file, and it'll generate a cargo.toml for you. So you can have a single file cargo program that you can go and run. And you can declare dependencies in it, which is something that you can't do with, say, a Python script. So you can be able to then take that, put that in your, what they call the shebang at the top of your file, and go and run it as a program. And it'll compile it behind the scenes and run it for you. And I think that that'd be something that'd be great for the Rust community. So there's cargo script, but then that kind of maintenance on that stopped, and there's been multiple forks of that project since. And I think it'd be something I'm really curious, wanting to explore is the idea of exploring what all versions of cargo script are out there, seeing, like, try to find a minimum viable solution between all of them for solving this problem, and seeing about getting this built directly into cargo itself. Because I know, again, I don't tend to install 20, 30 different cargo plugins. I tend to use what's included in cargo. So I've not really been taking advantage of cargo script because it isn't built in. I also know that there's been times where, like, on one bug report, I got something for a program called Cargo Play, which is a variant of cargo script, but I don't know how incompatible it is. So by having this fragmented ecosystem for these, it makes it harder for us to be able to create bug reports that people can actually go and easily run just makes it a lot more difficult. And so I think getting this embedded directly within Cargo will make it so we can reduce the fragmentation, have a good story around just having single file Rust programs that you can go and share, or be able to just open up an editor, run, and then delete immediately afterwards, whatever your use case might be.
Yeah, it's funny that you mention it right now because like one of the languages I use quite daily is Elixir, and they came up with this idea of like mix install or something like that, which is basically they're saying, hey, why can't we use Elixir for one-off scripts like you're saying, right? With Python, it's easy to script something out, go in its folder, do some funky stuff, and then get out. And for me, I still think it's a little bit weird. I'm not a big fan of it. I don't know. I don't really know what to think, to be honest. Like for me, I feel like maybe it could be useful in Rust. I don't know. I'm open-minded about this part. For Elixir, it's just the way the language is, it just doesn't make sense to me. But obviously Python, scripting languages like we talked about, makes sense. Rust, I'm not too sure. I just feel like, are we really making a big difference? Because now we're missing that cargo file. But it's not really missing, right? It's still there. But then in the background, you're still generating a project underneath now. So it's like, well, what are we doing? Now we're just kind of like doing some magic, right?
So I think some of that magic can be able to be removed by integrating directly into Cargo.
Mm-hmm.
But I think of it in terms of, at least for me in my development, the number of times I go on to the playground to just write out some Rust code. Because like Rust is statically typed. We've got docs.rs to be able to help find out a lot of details, but there's a lot of times where there's the semantics of how things behave that aren't as clear in some of the documentation, where you just need to try out the code and see how it behaves. The playground is great, but that only has a fixed set of crates in it, and you can't test it against files on your system. And so that's, I think, this is basically bringing the playground to your computer and allowing a little bit more flexibility with it. The other area where I think it's really useful is, in some respects, I feel kind of bad every time I automating something that I'm actually just going and like writing a quick one-off Python script. Like I have a script on my computer for backing up what all Git repos I have on my computer and then recloning them all for when I switch to a different computer. In some respects, I was like, man, why can't I write this in Rust? What's holding me back from writing in Rust? And one of them is the fact that it's just sometimes convenient just to have that single file just go and do things. The other is, I think, aspects of the standard library being focused on some lower level aspects of performance, of being zero cost, like you pay for what you use and everything's like that, where I think there could be value in something that's more like a Python standard library for Rust, where it provides high level constructs so you can just go and do things, like where you don't get nerd sniped into trying to cut down every single allocation you do. Like it doesn't matter if you want to clone this or not, just go and clone this, go and do all these other operations, cut down the number of language syntax things I have to do. Like never do reference, never have the borrow syntax, instead just clone it every time. And so it's just something that's a lot more prototype friendly, I think, from a library perspective, would also be a big help for the finishing the rest of the story, so I can be able to go and have those one-off scripts I might write be in Rust rather than being in Python.
And this kind of goes to another kind of question, which I asked you about the state of education in Rust. You definitely made a point that, hey, maybe we should look at doing something like Python-like, and this would be down that alley, right? Where you can just say, okay, you're a beginner, don't really worry about cargo, don't worry about workspaces. Just write your Rust code in here and you're going to be good. Something like that, right?
And reduce the number of parts of the language and parts of the like styling aspects that are more specific to Rust that you have to deal with as part of learning it. Like instead of presenting somebody with 3 or 4 different types of hash maps, just use index map and have people sort it if they want to sort it. So that way they just cut down the number of choices, because that's also one of the challenges is when you present too many choices. Like when I went to go adopt coloring into GitStack, me having to go and research the like 5 different, actually I probably pulled up 20 different color crates when I first wanted to add color to GitStack, and I had to quickly narrow those down to 2 or 3 and figure out why I wanted those 2 or 3, and that just took a lot of time, and that was a burden for me originally adopting color, was having to go through and make decisions. And so if we can be able to reduce the number of decisions, reduce the amount of encouraging people to over optimize things, if we can just make it so there's this path of don't worry about these details, just go and code and optimize it later, like improve those things later, don't worry about all those details yet, I think it'd make people a lot more productive in Rust and make it a lot easier to learn Rust and adopt Rust.
Yeah, I wonder if you get any kind of pushback from people saying like, well, if you do that, then they're going to be missing out on, all these other kinds of hash maps that I think you said that we should just ignore at the time.
Well, my philosophy with this is it's like the idea is not to say you can never do those things. It's not to split the language into 2 languages. It's this is your default path. This is the path for you just getting started, not worrying about things. And then when you have a problem, when something can't work the way you need, when you do have a hot loop that needs to be optimized, that's when you drop down and go and dig into those gory details. But then that's isolated into one area, very much like how unsafe works. You get the borrow checker, you get all these helps through all of your program, but there's times where it doesn't work and you need to drop down and have this small little section that is unsafe. So I think it's kind of like having unsafe, but that's having the safe versus unsafe parts of the language, but having a easy part of the language that's the majority of your code, and then having the more complicated part of your language being for that little optimization area. So I think it's that analogy applies for why to have these two different sets of things and how to get them to interoperate with each other.
Okay, I think made some pretty valid points. Yeah, I don't think I have anything else, but maybe there's something else that you wanted to mention before we start to kind of wind down. Maybe some calls to action. Sorry, what do you want to say?
Oh, actually, I was just remembering one last thing I want to add to that last point I was making, which
Mhm.
is I think before I'd played with this idea and I didn't really go far with it, but this last RustConf, there was both the talk about we need to break a lot of our assumptions about Rust to be able to make it more adoptable. Then there was also a talk that was a lot about just go and don't use all these complicated language features. Go and clone everywhere. So I think that helped to make me feel more confident that yes, this can actually be an approach that's not just going to get a lot of pushback. There'll still be pushback, but that there's others who are thinking along these kinds of lines that could be able to provide value. So getting to your wrap up and call for action, the things that I think would be great to be able to help with the work that I'm doing, it'd be great to be getting that feedback on Clap's design, to be able to hear a plethora of people's thoughts of here's how to be able to solve these problems. I have my own perspectives, my own background on being able to help solve these problems. I know there's people who have other great ideas for how to solve problems. I keep looking to completely unrelated areas for being able to get API ideas. Like Bevy, the game engine, I'm like, ooh, what kinds of things are they doing? Can we apply any of those to Clap? Can we apply any ideas from Bevy in a static site generator? So pulling in these ideas, getting this sharing of ideas, I think is really valuable. So I'd love to have feedback on how you think we can be able to help solve some of these API design challenges in Clap. I know it's not a very sexy problem, but it's always great to be able to hear other people's thoughts.
Yeah, it is interesting that Python's actually giving you some good inspiration for how you can make clap better and faster, right? A little bit feels like we're
Well, focusing on compile times rather than on runtime, because runtime's already fast
mm,
enough.
yeah. Also, compile time fastness. Okay. Yeah. In any case, right? So it's interesting that you're looking at game engines and things like that. But I mean, it depends on what you're getting from it. I mean, obviously, game engines they do want to display stuff. They do want to be quick. I mean, there could be lots of things you can get from it with their design goals.
I think for Bevy, a lot of it is the flexibility of things like an ECS and
Mm.
like what kinds of things are they doing with the language to be able to accomplish the ergonomics they want with it. So that's probably the two main things of the pluggability of a game engine and the ergonomics of a good game engine. Those are the types of things where it's like, oh, I want to learn lessons from that for how it can affect any of my crates, Clap or anything else I'm working on.
Yeah, I think the last thing I have to ask you about is like, you kind of touched a little bit on it, is kind of like tips for beginners or any kind of warnings for them. You have listed one over here. You could definitely talk about that. I never heard this before, nerd sniping. So,
So that's referring to an XKCD where somebody holds up a sign with a math problem as a mathematician is crossing the road, or a mathematician or logician, some kind of person like that. And they're like, wait, we could solve it that way. And then they just get so caught up in solving the problem they then get hit by a car. So it's basically like sniper on a field of battle, but using like a nerdy question for somebody to distract them so that way they get killed. Not the most positive thing, especially with some things going on in the world. But anyways, so the idea of nerd sniping comes from that XKCD, and it's something that I found a lot of times as I'm working on my Rust projects where I'm like, well, Rust gives me the control to be able to do this. Maybe I can optimize this one thing. I'm like, this is an area of the program that almost never runs. No one will notice the performance difference. I shouldn't go and try and optimize this. I should just go spend my time on a different problem. And I think that's one unique challenge of languages like Rust, C++, Zig, different languages like that, where the fact that we can do it means that we want to go and do it. And we need to make sure we step away and say, no, let's just go and do things in an efficient way. Let's just throw code at the screen, get it working, and then worry about have a profiler tell us what we should optimize rather than us being like, ooh, I could optimize this. No, it's not going to matter. Don't optimize it. Go and use, as that RustConf talk that I referenced earlier, go and use clones everywhere. Go and do things in a not performant fashion, in a not bare metal, best way possible fashion, and then make things better later. Make things better as you need them. Like, don't get distracted with all those details. Just focus on your problem.
Yeah, I think that's a good way to do it. But if you do want to go and try to optimize it, the bar checker will help you, as you found out with liquid templating, right?
Yeah, like I did with Liquid, where it's like I took out a whole bunch of different clones, and the compiler helped to both make it so it worked initially and that it'll work in the future.
Yeah, that's fantastic. Yeah, if there's nothing else, then really, I thank you for your time. We had almost an hour and a half chat, so that's fantastic. Hope I don't take up too much of your day.
Thank you very much for having me on here.
Yeah, thanks again.
All right.